Hello and welcome to another free code session. My name is Jason Bach and I'm going to do some more Pony programming and tutorials and all that other stuff. So last time I did one with Pony, we talked about errors and equality and sugar. Apply, create, and update. So that's what I went over in the last one. So we're going to continue on with object literals. So what is an object literal? Really convenient to be able to write a whole object in line, called an object literal. Object literal in JavaScript does. You know, I really don't do much. I honestly haven't probably written a line of JavaScript. Wow, I can't even think of the last time I wrote a line of JavaScript. Well, no, that's not true. For some of the Blazor demos that I do, I actually have to do some JavaScript for interop, but that's been minor at best. And I feel good about that because, quite frankly, I am not a JavaScript fan. Creates the object that you can use immediately by static type. So an object literal also creates an anonymous type. Oh, okay. Basically looks like any other type definition, but with some small differences. So it's an object literal because you have an object, it's anonymous, an apply, string, and hi. Explicitly provides an interface to make sure the anonymous type fulfills an interface. So it's hashable. I have to go back on types because I kind of forgot, like, you know, and actually let me do that. So you have classes, so you have class wombat, you can have fields, constructors, functions, that's all. Okay, that's a good. But then you have traits and interfaces. So traits, this thing is, right? And then you have structural, which is interfaces. So as long as the type matches the interface by structure, that's good enough. So, okay. So, that was a really quick refresh that I needed because I was like, you know, you say class wombat, but when you're here, you're just saying object. There is no class wombat because it's just an object. Okay. So what we can't do is specify constructors in an object literal because literal is the constructor. So how do we assign to fields? Just assign to them. Of course, it's just that simple. Use collections. Object is hashable. So we have a function of foo, and that returns a hashable, which the literal is. So it has a field string, which is the thing you're passing in. The apply returns a string, which is the s, and the hash is the hash of the string. When we assign to a field in the constructor, we are capturing from the lexical scope the object literal is in. Pretty fun stuff. This is complex closures. An object literal of fields is returned as a ref by default. Okay, I'm still not, these capabilities I don't quite get. Unless an explicit reference capability is declared after the object keyword. For example, well, okay, so you could declare a type, but then how is that returned? Because you just made the object. Oh. Really? Okay. This requires some stuff. So we're going to say, get rid of this. Okay. And what I want is a function here. And oh god, this is see, I really got to actually program. Let h be equal. Just gonna back everything out that was there. Yeah, because I'm gonna need that. I'm gonna forget what I did. And what I want is let h hashable, great name, isn't it? Equal foo JSON. Nope, not a semicolon. Forget the semicolons, JSON, okay? And then we want to do environment out print h dot, and it's a hashable, so we should be able to say hash string, right? So if we comment that out, and we do that, and I could do like h dot s plus, no, plus that, right? And let's see if that's runnable. You can find s in hashable. Okay. Well, we could just say h because we're using sugar, and you can find add in hashable. Fine. You know what? We can do that, and then we're gonna. I'm sure I'm doing concatenation wrong, and I'm just forgetting completely, and I'm being an idiot. Argument as subtype of parameter. I thought apply was like the default. So if I said apply here, you're going to find apply in hashable. Oh. Okay. Fine. We're just going to see, did that work? And it does. Okay, so interesting. So yeah, objects on the fly. That's actually an interesting thing. I thought I heard something. Okay. Yeah, all these capabilities I don't get yet. ISO, whatever. Capture variables, values from the lexical scope by using them in object literal. The values aren't local, aren't fields, aren't parameters. Are called free variables. By using them in a function, we are closing over them, that is, capturing them. The code above could be written without the field s. Okay. So in other words, I could just say, let's do a better name, value. So I could say value here, and I could say value here. I keep saying save. And that's just fine. Okay. All right, cool. Arbitrary complex lambdas. Arbitrary complex closures are nice. Sometimes we just want a simple closure. You can use the lambdas for that. Lambda is written as a function, implicitly named apply, close in curly brackets. We've seen this before. Yeah. This is produced as the same. Oh. So the lambda is actually part of an object literal that's made on the fly. Huh. Okay. The reference capability of the lambda object can be declared by appending it. Okay, so then it makes it an ISO. You capture it from the lexical scope in the same way as object literals. This is by adding a second argument list after the parameters. So, okay, well, let me back up here. So this is a literal, not a literal, this is a lambda that takes a string, returns a string, and well, the concatenation's right there, so I don't know why that didn't work before. I must have done something wrong. Okay. So here is the lambda taking the string, but we're also a second argument list after the parameters. Oh. And you can capture that way. Okay, so if it's there, you can capture it, so then you can use that to pass it in. And then that's just an object literal that has an apply that's taking a string, but is also closed over the environment. Okay, capturelist, and they create new names for things. So you could say it's equal to environment. Okay. curly brackets. Then the brackets, function parameter types are specified within parentheses. Optional colon and return type. The example uses string to be the type of the lambda function. It takes a string, as an argument, returns nothing. Right. If the lambda object is not declared with a specific reference capability, or from the structure of the lambda doesn't have any capture references, it will be a val. It will be a ref, a val lambda object. So a val lambda object, in this case, and these are these, what do they call these? This actually just keeps returning L until you get to this last one, and then this actually returns the value of push. And I forget, chaining, that's what they call it, chaining. Okay. So we have a, let's copy and do the old good copy and paste so we can play with this code. Okay, so we have a collection, I guess this is their packages thing. We have an actor with the create. We have a list of unsigned 32s, and so we push a 10, a 20, and a 30, and finally 40. We don't know what 40 is returning, but whatever. And then we let R be the reduction of the list was 0 with a lambda A and B, which returns a unsigned 32, where you're just adding A and B. Okay, and the result is R.string. What is the reduction? It is a function that takes a list, takes an variable names. People, do you speak them? Do you make them clear? You know, I see code like this and it drives me bonkers. You know, it's like, you know, call let, you know, integer values. Just name it something clear. I hate it when people do this. Sorry, a little bit of a rant, but it is what it is. Okay, so is this an accumulator? I don't know. This is a function that is a lambda that is expecting it to be of a U32 and a U32 returning U32. And that's a value. And then the whole reduce function returns a U32. So we go into a try block. We let this prime be what's calling F. We're passing in the L, the 0. Oh, shift. Does that pull out the thing there? And then you recursively call this with the function. And so what should come out of this, if I'm reading this right, should be 100. Yep, 100. I like this. I mean, I like a type-rich environment language, and with this, I get it. It's just trying to go through all of them and do an accumulation. Now, of course, you could just, I would assume there's a way to go through the collection and the list and just say shift and just keep adding them together rather than doing this this way. But, yeah. And this is a partial, shift is a partial call because I'm guessing that could fail. But since you have a try and an else, which if I look at my notes, a try else is a try catch. So this is when you do have an error, you just say return the accumulator, or the accumulated value, if you couldn't shift out, I guess. Okay. Val, the lambda object pass. So a val is if it doesn't capture anything, which in this case it doesn't. Okay. And if I remember right, with variables, oh, come on. I didn't say oh, that's horrible for me. That is horrible. Variables. Yeah, you can have, yeah, so var mutable or let immutable sign only once. Okay. Coming back to this. As mentioned previously, lambda desugars to an object literal with an apply method. Yep. Reference capability, also box like any other method. Still don't get that stuff. And a method that captures this needs to be a ref. If the function needs to modify any of the captured variables, are called ref methods on them. Reference capability for the method is defined by putting the capability before the parenthesized argument list. So in this case, we have a create which creates a list. We push hello world into it. We get a count of a U320. Is that the constructor on a U32 to say initialize it to a 0? I guess. Okay. Here we have a for each. We're taking the list and this is the lambda, which is a reference S string because we're capturing environment. And do count equals count plus 1. Display 0 is the count. For each, we take a list, we take a function, which is a lambda that has a string and returns a reference. Try calling f, which will print it out, and then you call for each again. Count have been incremented by the application of f. But reassigning a reference count inside of a lambda can never cause a reassignment in the outer scope. If count were an object with reference capabilities permitting mutation, an object literal is an synonymous class. Okay, and then that just makes it a B, makes it an actor. No fields and no behaviors. The compiler generates as an anonymous primitive, unless a non-val reference capability is especially given. In other words, in Pony, a lambda that doesn't close over anything has no memory allocation overhead. Nice. And actually, well, closure, and closures and doing closings are nice. Just by some of the complexity that I've seen here, you do also have that in C#. I tend not to do that if I can avoid it. You just can close over what's in your outer scope because that can start getting kind of confusing. I would rather have that being passed in, if at all possible, explicitly, and then, it makes more sense in my mind. Okay, so that's object literal. So let's do partial application, and then we're done. Partial application lets us supply some of the arguments to a constructor. And you get back something that lets us supply the rest. All this crap. Okay, I've seen this before in other languages. Okay. So we have a class that has a field, a private field, which is a float 64 0. A function, reference, again, I'm sorry, these things aren't making sense to me, but we have an add multiplier, or add mul. Takes an add and a mul. It says f is equal to f plus a, and then times the multiply. Okay. Weirdly named, but whatever. Then we have a class where you have an apply, and that's the most common one, where you're saying let foo equal to a new foo, and then you're doing a partial, the little squiggly tilde. So you're just passing in the add, and then you're going to pass in the, so you're partially doing this. You haven't done all of it. Okay. We partially apply the add mult function on foo. Yeah, again, names. Just the add, then multiply. Just say the damn thing, Binding the receiver to foo and the add argument to 3. Get back an object f that is an apply method that takes a multiply argument. That's called, in turn, calls foo add mult. We can also bind all the arguments. So this is just binding. You actually haven't called it yet. This is what actually would call it. We have none of the arguments. Okay. Partial application with named arguments allows binding arguments in any order, not just left to right. So you can do a partial application where the mult is 4 and then do the add. Okay. Partially applying a partial application. Object with an apply method. We can partially apply the results. So this is not doing any of it. Here we're binding 4, and then this would be the 3, which is the add. Okay. Makes sense. I think. Under the hood, we're assembling an object literal for partial application. It captures some of the electrical scope, its fields, and has an apply method that takes some number of arguments. This is actually done to sugar by rewriting the abstract syntax tree for proper application to be an object literal before code generations. This partial application results in an anonymous class and returns a ref and recover expression. All right, and that is expressions. And now we're going to start getting into reference capabilities. And I think this is, if I read the overview, I think this is going to be really important to spend time on. I don't know why. I'm just getting that feeling that these capabilities is a key part of Pony. And we'll see if that holds true. So I'm going to stop now, finish my beer, and go hopefully try to finish the book that I've been reading. The latest book on my, and I don't mean technical books, but just like, nonfiction or fiction, whatever. The latest one I've been reading is Bag of Bones by Stephen King, and I'm getting near the end, so I might be tempted to finish it tonight. We'll see. So that's all the time I'm going to spend on this episode. So thank you all for watching. Leave comments and questions below. See you in the next episode.